Hello. So today in your video we're going to talk about tangents and tangent lines to the circle. So if you flip open your packet to day 3, you should see this page. So let's talk about a tangent. A tangent is a line that intersects a circle at exactly one point. So for example, let's see, we're talking about circle P. So a tangent line touches the circle at exactly one point, which is right here. And that point, the point where the tangent touches the circle, is called the point of tangency. So now that we know what a tangent line looks like, let's look at some properties with that. If a line is tangent to a circle, then it is perpendicular to its radius at the point of tangency. So it's going to be perpendicular to the point at tangency. And if a line is perpendicular to a radius of a circle at its endpoints on the circle, then the line is tangent to the circle. So that means if you see, let's say we have circle O, and touches. So we have radius OR. R would be the point of tangency of the tangent of line T. So what this is saying is anytime we see a perpendicular radius to a point of tangency, we know that this line is a tangent. And we know that any line tangent to the radius is going to form a perpendicular angle here. Now let's look at some segments. So if two segments from the same exterior point on the tangent to the circle, then they are equal. So let's look at circle O. We're going to look at points A and B. So if two segments from the same exterior point are tangent to the circle, so let's look at So these two lines are tangent to the circle. Let's call this point T. So these two lines are tangent to the circle. So from our theorem it says that these two lines are going to be congruent to each other. So line AT is congruent to line BT. Okay, so if you flip to the second page in your packet, you should see examples that look like this. So we're going to use the theorems that we just learned about tangents to solve these problems. So let's take a look. Determine whether each segment is tangent to the given circle. Well, to be tangent to the circle, it's going to be perpendicular to the radius of the circle. So we can go ahead and put a 90-degree angle in there. Well, since we know all of our line segments, what do we know about right triangles? We can use the Pythagorean theorem. So if the Pythagorean theorem works, then we have a right angle. So our Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So these are our two legs. So we're going to do 9 squared plus 40 squared is equal to 41 squared. So 81 plus 1,600 is equal to 1,681. 1681 is equal to 1681. So, yes, the line is tangent to the circle. I'm going to flip down to number 7 on this page so that you can see how this other theorem works. So we're trying to find the perimeter of each polygon given the information. So here we know that segment QT is equal to 4. I'm going to put a 4 here. PT is equal to 9, so I'm going to put a 9 there. And SR is equal to 13. Well, from the theorems we just learned, we know that if a line is tangent to the circle, if two segments are tangent to the circle from the same point, then the segments are equal to each other. So that means that QU is also equal to 4, that PS is also equal to 9, and that RU is also equal to 13. And all we have to do is find the perimeter, so now we just add those up. So our perimeter is going to be 4 plus 4 plus 9 plus 9 plus 13 plus 13. So we're going to get 16 plus 18 plus 26. And we're going to come up with a whole total of 52 units. That's going to be it for your video today. Thank you.